So this is 12.1 part 2. We're going to talk about a little bit about geometric probability and just more events happening. So first is the idea of the complement of event. Not complement as in, oh, you look nice today. Complement as in goes with. So the complemented event is an event not happening. So the way we represent that is we write it with a bar over the event. So let's say the probability of A. So the probability of event A, we would write A with a line over it, with a bar over it, for the probability of not A. And it's since either something happens or it doesn't, it needs to add up to 100%. The chance something happens or it doesn't should add up to 100%. So the complement of something happening is the same as if you were to take 1 minus the probability of that. And it'll make a little bit more sense when we look at an example. So we can use complements, and sometimes that's easier. So let's say when you roll 2 dice, so we have the white dice and we have the black dice. If you roll 2 dice, there are how many outcomes? I could get a 1-1. Now, in this case, a 1-2 or a 2-1 are considered different because you're rolling 2 separate dice, or you're rolling 1 dice twice. The order does matter. So there are 6 possibilities you could get with the white dice, a 1, 2, 3, 4, 5, or 6. 6 possibilities with the black dice. And what we said in part 1 video is that if you multiply those outcomes together, you get the sum. So here, there's 36 possible outcomes when you roll a dice. So find the probability that the sum is not 6 or the sum is less than or equal to 9. So with A, I want to know that the probability that the sum is not 6. Now, here, so 1, 1, the sum is 2. The sum is 3, 4. I could count up all the possible ones, everything that's not 6. However, what might be quicker is using the complement. So, not 6, the probability that something isn't 6 is the same as 1 minus the probability that something is 6. And that's a lot easier because we can find the ones that the sum is 6. So we have 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1. So only 5 out of these 36 possibilities gives you a sum of 6. So if it's not 6, it would be the complement of that. Remember, we add and subtract fractions. We have to have like bases. So 1 would be 36 over 36. So the probability that the sum is not 6 is 31 over 36. Now you could have just counted all the other ones, but sometimes the complement makes it easier. So here, the sum is less than or equal to 9. Now, when you say less than or equal to, so the sum is less than or equal to 9, the complement of that would be 1 minus the fact that it's greater than 9. That might be an easier way to do it. Because which ones are greater than 9, all right? 6 and 6 is 12. Those add up to 11. These add up to 10, and those are the only ones that would give you a sum that's greater than 9. So that's 6. 6 out of 36. So again, without counting all of the others, if you find the complement, sometimes it might make it a little bit easier. So there's a 5/6 chance, it's a pretty likely chance that your sum is going to be less than or equal to 9. We can also use probabilities for geometry, especially in area. So with geometric probabilities, these are found by calculating lengths, areas, volumes, and dividing by the whole. So what do I mean by that? It's the same as if a favorable outcome over the total outcomes. So here, let's say I have no skill in darts, but so I'm equally likely to hit anywhere on the board. What's the probability I'll get a score of 10, so I get it in this main circle, a score of 5, or a score of 2 or 0 points? So what's the probability that I get those number of points? Well, it says each of these are 3. 3, 3, 3. There are 9 together. That means each of these sides are 18. Okay. So it's the area that we're looking for. The probability of an event equals the area of your favorable event over the total area of the board. So what's the total area of the board in this case? It would be 18 times 18. Length times width, which is 324. So the probability that we get 0 points, 2 points, 5 points, or 10 points. Let's start with the easiest one. What's the probability that we get 10 points? Well, the area of the whole is 324. And what's the area of just this? Well, the area of a circle is pi r squared. The radius here is 3. So that gives you 9 pi over 324. You put that in your calculator, you're going to get 0.09. So it's about 9%. There's a 9% chance that if you just fling your dart somewhere at the board, you'll get 10 points. Now, how about the probability of getting 5 points? Well, keep in mind, it's not the whole big circle with a radius of 6. It's that minus this inside part. I just want that outside. So it would be pi 6 squared, so kind of the bigger circle, minus that little circle in the middle, over 324. Put that in our calculator, we get 81 pi minus 36 pi over 324. You're going to end up with 0.44. So it's about 50% chance that you're going to get 5 points. How about the probability that we get 2 points? Well, there's this big circle with a radius of 9. And I want to take out this middle circle with a radius of 6. All still over 324. And that's going to give us 0.26. So you're more likely to get a 2 than a 10, but you're actually more likely... Oh, my apologies. I flipped these. So if you put this in your calculator, you're going to get chance at 5 points is 0.26. You put this in your calculator, you're going to get 0.44. That makes sense. It's more of a chance you're going to get fewer points. There's more area there. And then the probability that you get 0 points, well, that would be the whole square minus this big circle. So 18 times 18 minus pi 9 squared. Gives you 0.21. However, the other option, if you use the complement, would be, all right, so you start with the whole, but take away the chance that it's 10, take away the chance that you got 5 points, take away the chance that you got 2 points, and you're left with 21%, or 0.21. So at the end, if you do the probability of every possible event, they should add up to 1 if you're using decimals, or 100%. So please watch part 3.